Thanks for tuning into another Big Dave production. This is
Dave.
Dave 1.
You mentioned my name.
5-3 Dave 1. So the objective here today, we're going to put what we learned yesterday, which was factoring. We're going to put that to use today, and we're going to use factoring to solve quadratic equations. All right. First problem, just because Sydney loves them, is a word problem. Okay. And in this case, it's a kind of a projectile problem. So when we have a soccer ball kicked into the air, just like we launch we call those cannonball. Like we shoot a cannonball in the air, right? Or we throw something in the air. It makes kind of like a football. Like a football, yeah. It makes kind of like a parabola, doesn't it?
Yeah.
Like, if you think of it, if you think of it being thrown, and then you think of it flying through the air, and it's sounding like this, and then it goes towards the ground, right? That'd be like a parabola. So in this case, we could model that situation with the function h of t is equal to negative 16t squared plus 32t. This is a kind of a physics type connection. So some of you may remember some of this from physics, the acceleration of gravity. So let's determine when the height is going to be at ground level or 0. So when the ball is on the ground, what is the t or time? All right, so if we look at this function, we have h of t. So we have h of t is equal to negative 16t squared plus 32t. Right? If I want to know the height, when the height is 0, I'm going to put 0 in for h of t. And I want to solve this now for t. So negative 16t squared plus 32t, I want to know when that equation will be true for what value of t. So when it equals 0. All right, anyone, can you just look at it and just tell me what a solution might be?
0.
Good, 0. Yep. 0 would be a solution. Yep. And there's also one other solution. Can anyone look at it and tell me what the other solution might be? Oh, this is taking too long. We need to have a structure or a plan here. All right. Let's solve by factoring. So let's factor this, because this is a little happy little math book problem. So let's go ahead and let's factor this.
You can take a t out.
Negative 16t squared plus 32t. So we could take a negative 16t out of there. What we have left is, like an undistribute, t minus 2. So that equation is the same equation, just looks differently. It's in factor form. And now, if you think about this, we have kind of two different factors here. We have the negative 16t, and then we also have the t minus 2. And so there's this property that we cover in this section that is called the zero product property. Basically, it's you already know about this, but it's got kind of a fancy name. But it's like whenever you multiply something by 0, the answer is 0. Right? So let's do a little practice. Okay, ready? Keep track of this. Sydney's in the drill. Yes. 3 times 2 times 5 times 7 times 0.
What?
Oh. 0.
Zero.
0. Good. Yes. You got it. Good job.
Yeah!
All right. Take your easy back. All right. Let's try another one. Let's try another one. 5 times 4 times 3 times 2 times 0 times 1 times 8 times 7.
0.
0. See, because any times, I'm saying times, anytime you times by 0, if you're multiplying everything, then it ends up being 0. Okay, that's a 0 product property. So right now I have on the board, I have some red stuff, the red factor, negative 16t, and this doesn't have parentheses around it, but we could put them around there if we wanted. So negative 16t times t minus 2. So what value for t makes the red factor negative 16t 0?
0.
That is, I was going to write an x, but I wrote a t. That is 0. Oh, now I screwed everything up. Thanks. So what value for t makes that 0?
0.
That's going to be 0 itself. So in this case, t equals 0 makes the red factor 0. So that would be 0 times negative 2, which is 0. And the purple factor would be t equals 2. So that means at 0 seconds or at 2 seconds, that's when the ball is on the ground and has a height of 0. Okay? So we're going to start doing this solving by factoring here to solve quadratic functions. A 0 of a function is the value of the input of x that makes the output 0. So zeros are referring to when the y value is equal to 0. There's another word for that, and that word is also called x-intercepts. So the x-intercepts are the same thing as the zeros. Okay? Kind of a synonym there. So that's what we're looking for, are the x-intercepts or the zeros. I'm going to get just a little bit ahead of myself, but I think it's important just to kind of mention this right now. So I'm going to add a little slide in. When we're solving and we're finding zeros, all of these are parabolas. So what are our possibilities? How many zeros could we have? Well, a lot of times we have parabolas that just go like this, right? And it crosses twice. Yeah, so 2. Sometimes we have parabolas that might end up going like this. How many zeros does that have? None. This has 2 zeros. This one here has no zeros. So you might be asked eventually to solve an equation and it doesn't have any zeros because it doesn't cross. You also might have a situation where there's 1 0, and that would be when the vertex is your intercept. So that might be a case where you have 1 0. I'd say a lot of times we have 2, but it's not the only possibility. All right, so when we're solving and we're setting y equal to 0, we're finding the intercepts of x. I've said this like 10 times or more this year. At the x-intercept, we know that y equals 0. Yeah, so that's what we're doing. We put 0 in for y, and we solve for x. Okay, this is a really dumb way to do it. It takes forever. It would be like guessing and checking with a table. So we want to have a better structure and a better plan than this, so we're going to skip over that. Okay? And we'll do a more efficient method. And this method is to solve using our factoring. I talked about the 0 product property as well. And then I talked about zeros being x-intercepts, so that kind of highlights or goes back and talks about that again. So let's take this happy little math book problem that factors so nice and neatly for us, and let's find the zeros. So when it says find the zeros, that means I take f of x and put in 0. $9.59. Add it out, crazy simple. All right, so 0 equals, does this factor? Oh, better, it's the solve by factoring section in the book. Split in. Who can factor this for me? All right,
I
Aaron.
can, Mr.
Aaron will. Not all about Dave.
It is the day production.
True.
All right, Aaron. X and X,
X
are the signs different or the same?
are the same.
Because the last term, the constant's positive, the signs have to be
Negative.
minus minus. So 2 factors of 8 that add up to 6 are
4 and 2.
4 and 2. Good. So now that we have it factored, what value for x is going to make each one of these factors equal 0? So ultimately what we're asking is, when is x minus 4 equal 0? That's when x is positive 4. Same thing over here. When is x minus 2 going to equal 0? I know this is kind of like hyper thorough, but when is x minus 2 going to equal 0? At positive 2. So you start doing this enough, and then you start realizing, oh, okay, well then I can just look at that and go, x minus 4 will be 0 when x is 4. And it's kind of like the opposite of whatever that constant is. So you don't have to write out these equations. I'm just writing it out because I'm teaching it to you. But these equations are kind of what, if this is you and you're like, oh, this is what I'm thinking. You know?
No.
All right, next. Oh, look at that little snowman there. We actually had snow last night for the first time this year. If you're listening to this in 2042, this is 2018. It is November 29th. So, does this factor? Want to find the zeros? We're going to put f of x as 0. Factor it, x and x. Are the signs going to be different or the same?
Different.
They're going to be different because the last term is negative. So now I'm looking for 2 factors of 12 that have a difference of 4.
6 and 2.
6 and 2, and I want more negatives, so I'm going to make the bigger number go with the negative. Good. Now what makes x plus 2 0? Negative 2 and positive 6. So negative 2 or positive 6 are the x values that make that equation true. Okay? This next one's a little different because it has no constant term. So if it does not have a constant term, then I can factor out an x, or in this case a 3x. Take a 3x out. I have an x plus 6 left. Okay. So that will be 0 when, if I put that in parentheses, what makes 3x 0? 0. What makes x plus 6 0? Negative 6. So 0 or negative 6 are the values for x that make this equation true. Okay. Same thing. Find the zeros of the function by factoring. This is like my favorite trinomial right here. I love this one because it's tricky. Tricky. All right, when you factor this, you go x and x, right? All right. Are the signs different or the same?
Different.
Different. So I'm going to go plus minus. Now this is the tricky part.
6 and
6
1.
and 1.
2 plus 3 add up to 5. And 6 and 1 have a difference of 5. So you really have to pay attention to what the details are here. And the details are that we have to subtract them. So we need to go 6 and 1 instead of 2 and 3. And the 6 needs to go with the negative because I need a negative 5 in the middle. They need to add up to negative 5. So my two solutions now are what makes x plus 1 0 is -1, and what makes x minus 6 0? +6. This next one is one like the ones we did, but it doesn't have a number in front, so sometimes these little differences give people trouble. So in this case, I factor out an x, and I'd be left with x minus 8. So after I factor out that x, my solution for what makes x 0 is 0. What makes x minus 8 0 is +8. So those both cross the x-axis in 2 spots. All right. Any questions? Are we good?
We are good.
Moving.
Good, Chief.
These are just like happy birthday.
Love
That's
it.
what. That's
Thank
what. Yep. That's what Frosty said.
Mhm.
Remember that? These are a little different. So
Subtract.
when there's no f of x in this one, so we want to set the equation equal to 0 if we're finding the roots. So when you're solving an equation, you find the roots. So you're essentially doing the same thing. You're just making the equation equal 0. So I want a minus 25 to the other side, set it equal to 0. Okay. Now this is the difference of squares. Maybe you recognize it, maybe not. It's also the same as 4x squared plus 0x minus 25. So how does this one factor? Well, 2x and 2x because it's the difference of squares. Perfect square, 5 is 5. 1 is a plus, 1 is a minus. This is a little different. We haven't ran into this yet. What makes 2x plus 5 0? What makes 2x minus 5 0? Students have a tendency in this case to go and say, oh, it's 5 and -5. It's not 5 and -5. Okay? And you might want to make a little equation here just to kind of get the hang of this or if you forget what to do. When is 2x minus 5 0? Well, subtract 5 from both sides. 2x equals -5. Divide both sides by 2, and x equals -5 halves. Right? If I do that over here, I get the same thing, but it's the opposite sign. 2x equals 5, x equals 5 halves. So positive 5 halves, -5 halves. There's a little kind of pattern to this. It's always going to be, when you get your factor, it's going to be the opposite of the constant term, which is positive 5, divided by the coefficient of x, which is 2. Okay? All right. Good? Now we got one over here. It's a little different because we got to factor some stuff out. We got to set it equal to 0. I always want to keep my leading coefficient positive, so I'm going to move the two things from the right side to the left side. So I'll make it a minus 48x and a plus 32. Set that equal to 0. In this case, I can factor out a
6.
Oh!
9x squared minus 24x plus 16. Any mistakes there, people?
No.
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 No, sir.
All right. Now I'll factor this. Let's see. Factor that. 9x squared. Those are perfect squares. 9x and 16. Let's take a peek at, let's see, 3x and 3x. And let's go 4. Oh, I'll be Galdang.
Mr. Bolio.
You will be Galding?
If you're subtracting the 18x squared over, what the
I'm not
18x
doing that. I didn't do that. Thanks for listening to what I said.
Wow.
I moved the 48x. Check the tape. Check the tape.
Oh, I see. I
Yeah.
totally just messed up my thought process. I was right.
And I didn't do that. And I didn't do that because I don't want a negative leading coefficient.
Dave.
I feel.
Oh, no.
Come on, Dave.
Come on,
Bruh.
Dave.
You and Jada keep chirping each other back there all hour, and then you're out past a little bit. Now you're getting busted on film. I mean, on tape. I mean, there is no tape. It's digital. So what makes 3x minus 4 0? 4/3, good. Opposite of -4 is +4, divided by 3. What makes, over here, the opposite of 4 is +4? Wait a minute, they're the same. That's weird. Oh, this is the one where it is the vertex. The vertex is the root or the 0. Yeah, it's the one where the vertex touches. All right, good. Let's wrap this up. We're at 20 minutes. These next two are kind of the same, so let's just skip them.
Oh, really? Okay.
Yep, that's fine. We got kind of enough problems here. Let's go straight to the last part. This is working backwards. So let's say we have a quadratic function in standard form, but it gives me the 0 of 5, and it gives me a 0 of -5. So if 5 is a 0, then what is a corresponding factor? And if -5 is a 0, what's a corresponding factor? So we're just working backwards. Anyone? X minus 5, good. And if -5 is a 0, then x plus 5 is a factor. Is that in standard form? Not quite. I got to multiply it out. Multiply that out, and you are going to have x squared minus 5x plus 5x minus 25. Look at there, it's a difference of 2 squares. X squared minus 25 is the function that has the zeros 5 and -5. That makes sense, working backwards?
Yeah.
Okay, the last page is the same, so we'll do the top one and we'll skip the bottom one. So the top one is going to have zeros of -6 and 0. So this one's a little different because if -6 is a 0, then x minus getting plus 6 is a factor. And if 0 is a 0, then what's a factor? X minus 0. That's silly though. Nobody would ever put -0, would they? Yeah, this is where you just would do x.
Trippy.
Yep. So then the function for this one, when you multiply it out in standard form, would be x squared plus 6x.
Weird.
Good. All right. Now you guys are ready for the real world. Okay?
Yes.
All right, there you go. There is the assignment. And this is Mr. Bolio signing off, 38 years old.
Yo.
Great.
Bye.